To Unlocking Nature. Unlocking Nature is the virtual campfire where we tell the story of African conservation. The management of Africa's many elephant populations is one of the most sensitive and delicate topics that one can discuss. On the one hand, human-elephant conflict can lead to loss of property, loss of livelihoods, and even loss of life. On the other hand, elephants remind us of everything that's good about being human. They show affection, they show friendship, intelligence, and they even sometimes lose their temper a little bit. All of this plays out against the backdrop of many often less than ideal social and government systems. So it is with this in mind that we will this October bring you a panel of experts to give you a deeper understanding of the complexities of managing our elephant populations. Join us with an open mind. We will not offer you one solution, but many perspectives. And with that, I would like to offer you a little glimpse of next week's presentation. Dr. Janetta Salier and Dr. Sam Ferreira is in the audience tonight, so they might welcome to comment. And I know Marette is going to share a talk description in the chat if you want to have a look at that. If you look at the title and it stirs something in you, don't miss it next week. It is a sentiment that is living in many people's minds, and at times when we look at landscapes, that thought crosses our mind. So let's deal with it in a constructive way. And now I would like to move on to tonight's presentation and start by welcoming Dr. Robert Guldemond. His interests include maintaining and restoring connectivity for elephants across Southern African conservation landscapes. He focuses on understanding the drivers behind population dynamics, demography, and dispersal of elephants among protected areas. And we will drop a link to his full bio in the chat. But with that, I'm going to stop talking and give him the screen. Robert, thank you very much. Welcome.
Thank you, Johan. Thank you, everybody. So we with the Conservation Ecology Research Unit within the Department of Zoology and Entomology here at the University of Pretoria. So when we think of elephants across Southern Africa and South Africa, there are some similarities and dissimilarities between the conservation estates. Across the continent, conservation estate is fragmented, likewise in South Africa. Across Southern Africa, some of the protected areas are connected, whereas in South Africa, almost all of the protected areas with elephants are fenced, isolated, and can't disperse. Across Southern Africa, again, there are a few insular populations fenced in, and then on the South African side, we participate on 3 trans-frontier conservation areas, meaning that we're linking elephant populations with our neighboring countries. When we talk about elephants, when we think about elephants, and when we do our work, we know that we can do better. Currently, the best estimate is that we are on about 25% of the potential number of elephants that we can have across the continent, the whole continent. Therefore, elephants are still classified as endangered, or the savanna elephants still classified as endangered animals, and those African forest elephants as critically endangered. So I would like to start this presentation just with this very, very simple model for everybody to understand, and myself as well, about how we think about population sizes. Along the horizontal axis, the number of animals being born feeds into the population increases, the number of elephants dying decreases the number or lower the number in a population for elephants and all animals alike. The same along the vertical axis. If animals move and walk into a population, of course, the number increases, and those that leave the population will let numbers go down. Now, this allows us a few very basic models to evaluate what we can expect to happen. If the number of animals being born and the number of animals dying equals each other, then there's no change in the number of elephants that we may expect over time. The same for animals walking into a population and those walking out of a population. Again, if the number is the same, there would be no change in the population size. Two alternatives to this exist. If the number of births, the number of animals born into a population exceed those that are dying, you may expect an increase. These aren't real numbers. This is just a projection, just a model that we can expect along the vertical axis. And when it comes to animals walking into a population and those leaving, if it exceeds those walking in, again, you may find an increase in the number of animals within your population. And of course, the opposite is true. If more animals are dying than those are being born, your population can decline. And if more animals leave your population and than those walking in, then also a similar trend. So what would happen if we remove one of these ecological processes determining a population size? Let's say, for instance, we put a fence around a population. Then obviously no immigration can take place, and the population size is only determined by the number of animals born and those dying. So this graph falls away, and what we typically see and what Professor Rob Slaughter and his group perfectly named and called, we get this sort of like eruptive growth, especially in establishing new populations, a massive increase and a quick, fast increase. Now, we all aspire nowadays to try and halt this population increase by lowering the number of births. We're trying not to interfere too much with the number of animals dying, and we're trying to suppress birth in order to get that growth to decline. A number of people later in the month will talk about actions being taken to try and achieve this. However, in an ideal world, if dispersal is not an option, we would like to have the births and the deaths sort of like balancing each other out to again attain a zero growth rate, or at least a stabilized growth rate. Now, of course, and one of the ways to reduce density or the number of animals is live capture and transportation. If any one of you have been involved in an operation like this, it is very impressive. Across the sub-Saharan Africa, lots of operators are very good with this. This has been done numerous times. We're very successful, and every single translocation without a death is certainly regarded as a success story. So we keep that in the back of our minds. But there may be others talking about this later during the month. Right, so we need to go back to the very, very original model, simply because in an ideal world, when all ecological processes are perfectly in place, animals are free to move into a population and walk out if they want to. Those that are being born are being sort of balanced out by those dying in order to get a very stable population size over time. However, these assumptions need to be tested. scientifically. You would think that this has been done since this basic model has been in existence for eons, for decades, and it's only recently when we started paying a little bit more attention to it that we thought out that this basic, very, very basic model needs to be evaluated. So for the time period just preceding the COVID-19 pandemic, we scrutinized the public literature and found literally thousands of survey estimates of elephant population sizes. And we abided by very strict criteria set out by the African Elephant Specialist Group, criteria A and B, to only include those best survey results in order for us to evaluate this model. And eventually we got enough surveys being published for 103 elephant populations across Southern Africa. Now, if I say Southern Africa, this is broadly the SADC countries, including the southern part of Tanzania. This gave us about 713 elephant surveys to work with. And we did this from 1995 to 2020. From 1995, we chose simply because it's the post-culling era for especially big populations like in the Kruger National Park and other places, up to 2020, which gives us about 1 generation interval. Now, a generation is basically described as a female elephant being born, and the moment she becomes a grandmother, it's 24 years later on average. So we regard that as a generation interval where a number of ecological or processes take place, be it disturbances, droughts, etc., etc. And we use the density independent diffusion approximation method. Now, this is a growth rate that do not tell you about the mechanisms behind elephant growth and dynamics. It's merely an index or a growth index that gives you an idea for comparative purposes, because it can allow for missing survey results, etc., etc., perfectly suited for what we wanted to do. So what did we found? In blue illustrates those populations with a growth rate which is exceeding that we can expect from demographic rates alone. So something else is happening here. For instance, it may be boosted by elephants moving into a population over the 24 years, giving us exceptionally high growth rates. Those marked in white are the elephants that are relatively stable. They fluctuate around the zero growth rate plus or minus what the demographic rates would typically allow you to do. And those in red, these are the populations that things aren't going as well as we would expect them to go. Some of them are declining fast. Some of them have lost all the elephants over a 24-year period. And so that gives us an indication and a broad perspective about what's happening at the SADC level of elephant dynamics. So our work has been followed up by a number of others that have published, coming up with a number of ideas about how we can be better about improving the life for an elephant, and which we fully agreed on. One of our colleagues, and Dave is also in the audience here, which is wonderful. They reflect on workable solutions for the future on how to address the shortcomings that we've experienced over the last 25 years or so. There we go. But yeah, overall, the growth rate is 0.16% across the whole Southern African region, which we regard and tell the story that this is a success story. let's say 40, 50, 60 years ago, this number, 0.16, would have been a minus declining due to several poaching incidences and drought and management and all sorts of things like that. So we regard this as a success story in terms of what we've achieved over the last 2.5 decades. But we need to unpack it a little bit more, what that overall value means. For instance, when we talk about insular populations, now that was included into our larger assessment. Insular populations are those that are fenced in or they're surrounded by developments around a protected area where elephants can't disperse. So effectively, it's just births and deaths alone. And on average, a near 3% increase with a high level of variation simply because of what happens to some of the populations abroad. When we talk about buffer areas, now these are sort of like IUCN category 5 and 6 or non-assigned elephants. So these are areas connected to protected areas, but they don't receive the amount of protection that you would typically find in primary protected areas. A small buffer area are those areas with less than 1,000 elephants, and a large buffer area with more than 1,000 elephants. These are substantial numbers, but the weighted growth rate that we've calculated for them is declining or shows trends that are very much in a negative line. In a similar manner, small and large core areas are primary protected areas with an IUCN status of 1 to 4. And here we see positive growth rates for both of them. Most notably for large core areas, those well-protected areas with more than 1,000 elephants across the landscape, they have a near zero growth rate with some variation around them. The small core areas have a very large, very high growth rate, but linked with that, a very high level of variation over the 24 years, meaning that animals are moving in and out of them at rapid and very fast rates on an annual basis. So just to conclude, what that study tells us that if we protect and connect sufficiently sized conservation areas, we may be able to stabilize regional population growth to a near zero, meaning that the number of animals born into the population is counted by the number of animals dying or elephants dying in the system from natural causes, and those that are free to walk into a population are also free to walk out of a population and disperse accordingly. Now, closer to home is what we call the fortress conservation model. Stand to be having some severe challenges, and this is mainly the broader theme of this month's discussion. We know about the risks associated with small parks and small populations, eruptive growth, obtaining high densities. There's some severe concerns about the impact that elephants have for these regions. And any intervention mechanism that we put into place is costly or are costly. It costs a lot of money. If the money dries up, then we're back to the original problem by not abiding by the ecological principles that we would like a large mammal to function as. So, of course, with conservation successes comes new challenges. Apart from what we know what to do to be able to be better at protecting those areas that are being influenced and affected by illegal activities such as poaching. When it comes to dispersal between protected or primary protected areas, it brings elephants and other wildlife in closer contact with people living in the landscape. And we sort of aspire across the whole continent to turn perceived conflict into acceptable levels of coexistence. And I'm saying perceived conflict because it means different things to different people and acceptable levels of coexistence for the very same reason. We all save in our houses, and some other people aren't. So, by and large, our mantra is connect to protect. That's what we work on, and we are facing all the challenges that comes with it head on from a scientific perspective. A lot of our work has been inspired by a vision that the late Rudy van Aarde had, captured in his book that he produced post his once he left us, and sure to check out this book. It certainly explains anything and everything in a much better way than I could ever do with this presentation. Thank you, everybody. This was a very short, brief introduction into the whole month, and happy to take any questions after Bernard has done his presentation. Thank you.
Rob, thank you so much for opening the session for us. With the context that you set, really appreciate that. Ryan Davey, I can see your hand is up. Can I ask you to just please be patient? We are going to allow for a discussion and question and answer session as soon as Bernard has done his talk. It's just to allow for the whole scene to be set, and then we take it from there. I see there's a lively discussion in the chat. Please stick with the whole series of talks, especially the KZN context. There will be a number of speakers coming straight from that context, but as this unfolds, I think it will add more light onto this as well. With this, I would like to introduce our next speaker, Dr. Bernard Coetzee, who does fieldwork from Antarctica to the tropics and everything in between, including African savannas. He studies everything from mosquitoes to elephants, and his work on mosquitoes actually looked particularly interesting. But tonight we're on to elephants. Recently, he was added to the prestigious The Explorers Club 50 class of 2025. So it's our honor to have him here tonight. And Maret will also drop a link to his full bio in. Thank you so much. Bernard, the floor is yours.
Thank you, Si. Good evening, everyone. And it's nice to see such a big and wonderful turnout. And thank you for your time. Thank you for the LSA to putting this together. And I look forward to this month of talks. And so, and thanks also to my colleague Rob for giving us an overview of the situation for elephants in Africa more generally. But I think a burning question in a lot of people's minds is what happens to elephants in insular and isolated protected areas. And I'll touch on that tonight. And so I want to talk about these insular elephant populations, and I'm going to touch on two case studies. The first is in Kibale National Park in Uganda, and it'll be light. It'll only be a few slides, and then I'll briefly discuss Manikwe Game Reserve, which is very much hot on the press at the moment. And so the aim really of the talk is to highlight the problem. I want to put you in the seat of a manager or a decision maker that has to sit with these very contentious issues and this very different perspectives of people. And I'm not here advocating a single position. I really want to teach the controversy, if that makes sense. And the other challenge for giving a talk like this is that I know that it's a very broad audience. And so especially the beginning of the talk is really pitched at probably an undergrad level. And so for the older salts in the room, I see there are a lot of them on the talk. Please be patient as I go through that. A lot of what I'm coding is directly from the text that I also studied as a student. Okay, so African Savannas 101, and this is a deep and complex issue, but it's really important to understand the context at which a lot of this is playing out. And so these trees and grass ratios in African savannas, but globally also for savannas, are basically governed by these three factors: herbivory, rainfall, and fire. And the study of their interplay and is really lies at the heart of ecology and at the heart of how we are trying to understand these major patterns. And so I pulled this semi at random from a recent paper. This is a paper on the trophic interactions between different species in African savannas. And I don't mean to pick on this paper in particular, but it's almost certainly incorrect, right? They make some assumptions about positive and negative interactions. This is based on assumptions. There's a couple of unknowns, but they, for instance, have no interactions between large-bodied predators and mesopredators. Of course, they interact with each other's. There's some weird interactions with termite mounds and fire that are negative, but fire doesn't influence termites, but surely they do because it changes biomass. And then at the top left is a mega herbivore, which seemingly doesn't interact with the other animals, but only on seedlings and very big trees, but not grasses. Okay, and so I'm not trying to pick on this paper in particular, but just going to show that it's a complex issue, and a lot of work is ongoing to try and really understand and tease apart these different drivers and what that really means for the functional role that elephants play in these systems and savanna systems. And so in terms of elephants and their functional roles, and this is again the undergrad introduction, they are a mega herbivore and they do mega herbivore things. So they have localized effects. They do push over big trees. They forage. They need a lot of forage to sustain them. But I think it's important to highlight now already, and it'll be clear in the next month, that impact does not necessarily scale linearly with numbers on the ground, right? It's really context specific, and that's because the impacts of elephants and elephant distributions at the local scale is not linear, right? They attracted to water, for instance, or they get fenced in and the impacts get compounded. And so it's wrong to think that we can simply tie a number to impact and that's a linear relationship. It's almost certainly not the case. In general, and I mean in general in terms of wildlife management, the smaller the area, the more management is required to reach some outcome that you want to achieve. And what you want to achieve is really up to the people setting those goals, right? There are different ways to achieve that. And in general, especially for elephants, there's more potential for effects if the habitat is altered, right? I think it was absolutely what Rob could demonstrate in his talk. If you introduce fences, so you close off the populations and you introduce things like artificial water, you really change the natural dynamics at which elephants operate and function. Okay, and so there's a lot of interest on the localized impacts of elephants on vegetation. And so I can nitpick through the literature and pick a lot of cases, but I'll pick one that I wrote or work that I was involved in. And this is sort of an example of the kind of studies that people can do at the local scale to try and understand elephant impacts. And in this case, this is one of the long-term exclosures running in the Kruger National Park. And these Petersinia palms are inside the exclosure that excludes elephants and importantly also excludes everything else, all the other forms of herbivores. And here these palm trees grow really, really big and really tall. But outside of the fenced areas, you can see here to the right, they're small and they get shortened off. And the point we were trying to make with this paper is that these trees only reach sexual maturity at about 5 to 6 meters, and then they can start setting these big seeds. And if they're kept short like this, they don't sexually reproduce. So this species can vegetatively reproduce. And so at a species richness level, this has no impact from elephants, but it makes a structural change in the canopy structure of the plant, right? But again, I say this can't only test for elephants and elephant impacts because that fence keeps out everything else. And so it's an artificial system in the first instance. And I highlight this as a typical case study where people try and understand these localized impacts. And you can go through the literature and you can find multiple of these examples. And the key really is, how do you cut through this noise? How do you cut through all these different examples and how do you put it all together? I'm a meta-analyst, and so I think the best way to do that, of course, is through a meta-analysis, and that's basically where you analyze a combination of analyses. So you put all together all these localized studies and you put them together in one way, and that way we can form a broader, sort of richer perspective, really, of what the full suite of different functional roles are that elephants play in a landscape. And some work of Rob, that was the previous speaker, showed that rainfall and fences influence elephant density related impacts on vegetation, and that the results really are site-specific. And it gets mediated, is the point, by things like fences and rainfall. Okay. And so onto the case study, I want to highlight two sort of very different origin stories that are probably playing out across much of Africa, right, in creating these insular populations. And so if you speak only from a typically South African perspective, we think about fences and we think about artificial waterholes. But I suspect that in many landscapes, the causes for insularity in elephant populations are varied. And so this is just one that I was fortunate enough to see myself. And so I highlight that as an example, but I'm sure in your own landscapes and the places you are across the continent, you might be able to think of different ones. And this is in Kibale National Park, which is in southern Uganda. And I'll zoom into this map in a second. And so Kibale is a hyper-diverse tropical forest. It has the highest primate density in Africa, and it is home to an astonishing amount of birds and plant species. And so it's really one of the hyper-diverse parts of the continent. But elephants have become isolated in these rainforest patches through habitat transformation. And when I say elephants, I don't mean Loxodontus cyclotis. I mean the savanna African. And so there are savanna elephants stuck in these forest patches. And because of this landscape transformation between the border of the DRC and Uganda, they've lost their connection to their source pool, which is Queen Elizabeth National Park in the south. And so this might look like a patch of suitable habitat, but it's in fact Lake George. So that's a water body. And there's some early genetic work that has shown that this is probably a hybridization zone now between savanna and forest elephants, because these two populations have been squashed together, and the elephants are struggling to move. The African elephants are struggling to move out of these forest patches. It's very difficult to know exactly how many elephants there are in there. Duncan's put them at about 600 individuals in this 790 odd square kilometer forest. So at the moment, quite lower densities than elsewhere on the continent. But I think it goes to show that some of the insular issues that I'm going to talk to in a lot more depth now with Madikwe are true for other pockets of Africa. And so what the consequences of this is, I don't know yet. I think it sort of came to my attention only very recently, and I think it sort of goes to show that this is something that people and managers and conservation practitioners really need to highlight and think about. But I want to talk mainly about Madikwe Game Reserve, which was established in 1991 for wildlife restoration and ecotourism in the northwest province of South Africa. It's highlighted there on the map. It's also a big reserve, almost 750 square kilometers, and it's home to the big 5 African wild dogs and more than 350 bird species. So very diverse. But it is fenced and it is also isolated. The landscape around that near Gaborone, the capital city of Botswana, is very much degraded and unsuitable for elephants. And it has a rich history of introduction basically from all over. So elephants were first introduced from the Kruger National Park in 1992. In 1994, there was another introduction event from Gonera Zoo in Zimbabwe. Then some more bulls from Kruger. In the early 2000s, animals were translocated. And from 92 to about 2007, we were aware of 22 animals legally hunted within the reserve. And so this is really a mixed match population, I think. And at the moment, Madikwe is sitting at around roughly 1,700 elephants, and it still maintains a high population growth rate. And so this is a graph compiled from existing data and count data that we added from helicopter surveys done last year. And just look at the portions of these graphs. From about 1994 to 2006, the growth rates were about 5.2%. But in the last maybe 10 to 15 years, the growth rate has increased. And so there's growing concern from a variety of sectors if intervention and a management scale is required in this population, because we can show this exponential growth rate and it's keeping on going. And so, like I say, again, to put all this together from existing studies is hard, but I'll just highlight one of them. There was a recent study published on the long-term effects of elephant-dominated browser communities on the architecture of trees within and outside of Madikwe. So they tagged 3,500 trees and followed them over the past 20 years, right? Revisited those sites. And now, interestingly, the number of trees utilized by elephants increased, right? So they tend to go to more different kinds of trees, but there's not an increase in the destruction effects on individual trees. And so what happens is there's almost, or these authors contend that there's a hedging effect. So the elephants sort of push down trees in the upper canopy of these trees, not necessarily reducing species richness or abundance, but push them back in the browsing trap where other ungulates and other browsers can get to them. Okay, but the Madikwe situation is an extremely hot topic. If you anywhere near the elephant debate, you realize this. These are just a few screenshots of papers I took from last week. There were additional two articles published this week about the different about Madikwe and what should be done, and if something should be done. And the arguments get quite vitriolic and animated. But let's, for instance, run through some of the practical options that people could consider. And like I say, I'm not taking in a position here, but I want to point out some of the pros and cons to each. And remember that this really is a highlight talk. The other authors and the rest of the speaker series will really get into the details of what a lot of these options are. And so you might say that you could do nothing as a management option, and this is not a cop out. This is a thought through management a decision that could be made on the ground there, right? And so the pros for it is that it's cheap. You're not intervening directly. It's cheap in terms of resources, not necessarily money, and it may achieve density dependence, right? And so we know that for larger protected areas, density dependence can be achieved. Okay, and there's an opportunity then to really study the functional roles of elephants. But I think in the case of Madikwe, especially because it's so hot in the press, it's going to be controversial if a step isn't taken at the moment. And especially if less direct interventions are added, like closing water holes, right? And so the closing of artificial water holes in the Kruger National Park, in my view, has been a resounding success, because that really changes how the elephant dynamics work at the landscape scale and forces them to retake their natural dispersal patterns, as Rob pointed out. Another option might be to trophy hunt. One positive about trophy hunting that I think a lot of people don't highlight is that it's proactive in trying to generate funds in this process, right? It's saying to managers, look, there's a way that we can create funding opportunities with this. But of course, it's also controversial. And it's less effective at controlling the actual numbers of the population, because typically hunters focus on mature bulls, which is not where you have the biggest impact on changing a population trajectory. And then, of course, you can also consider culling in an area. Of course, it's culling. The positives is that it's a very fast management intervention, and it's effective at reducing the pure numbers of animals, if that's the thing that you're after. But it's very controversial in a variety of different spheres, and I think it really is a short-term solution. It's not really getting to the root of the problem. It's a short-term solution. And it's counterintuitive, because there's some outcomes could happen in culled populations, like it actually increases population growth rates. So that's not the absolute numbers of elephants, it's the growth rate, so how quickly they're reproducing. And I think there's also risk of substantive political backlash. I don't just mean people that are opposed against culling. I mean at a broad international policy level, some really big mechanisms like the CBD, and CITES, we might lose our international negotiating power and standing and financial backing from these big mechanisms if we, as a country, decide to cull. And so it's very hard to know what the consequences of those sort of actions would be at a broad political landscape. Options, I'm putting sterilize as a word there, but it really is a immunocontraception that could be either to the females or to the bulls. There's a variety of ways to do that. And we're dedicating a series of one of the talks in the series, especially to immunocontraception and its pros and cons. Its pros is that it's very effective in small reserves, especially for smaller populations. But there are some concerns that it can change social structure of the animals, and it can be costly at large spatial scales. One of the options might be to translocate. That's also a relatively fast option. As Rob alluded to, we have a lot of expertise in this country to be able to do it, and it's effective at reducing numbers, right? If that's your thing. But it has to deal with source sink dynamics, and so the Madikwe might be a source of elephants, but where do they go? And there aren't that many sinks left for elephants at African savannas. So where do they move, and who wants them? And it can also be expensive, especially if you scale it. And moving 100 animals, I think, does very little to population densities, we really have to move a large portion of the population if we can have an effect on population densities and growth effects. Okay, and then the other nexus of solutions is really the protected area expansion or connecting landscapes, and I think over a long term that's a really only long-term solution. But also it's slow, right? It's a slow process, and importantly, it requires cooperation. It requires cooperation between governments and agencies, and often it can be very expensive. So this is just a conceptual graph that I want to run you through, and maybe you can do this on your own time after the talk or whatever the case is, just to see where you sit with your value systems on how these different interventions play on different axes. And like I say, these are synthetic axes. They're not real. They're not underpinned by real data. But this is sort of where I see them play out in terms of the cost of an intervention, in terms of its social cost, or its money. You know, it could be money, or it could be a social cost. It could be risk of doing it, and then its effectiveness. Now, importantly, the kicker here is effectiveness for whom, right? And so it depends on what you're trying to achieve as a management objective. If you're simply trying to reduce numbers, there are a variety of things that you can do. But if you're really trying to preserve in a holistic sense, the ecological functioning of your park, you have to think about different measures of effectiveness. And remember that these are synthetic axes. So these little dots can really move anywhere you want, depending on your value system or your underlying understanding of your system. I'm not very hard-pressed on where they sit, but I want to run you through the gauntlet of decisions and how that plays out in the real world. And so you might say that doing nothing can be quite effective, and it's not going to cost a lot. Hunting isn't particularly effective at controlling populations, but it might make money. The sterilization options could be costly, but they're broadly effective. Culling could be effective at reducing numbers. It might not do much at population growth rates, but there might be some real social risks and social costs at implementing culling at scale. And then you might, put translocation and particularly expansion together. And I think as Rob could show with actual data across the continent, really, if we connect these landscapes, that has the largest ecological effectiveness for the conservation of elephants. But it does come at a cost, right? It takes a lot of time, and it requires a lot of buy-in and input. And the really important, I think, take-home from this exercise is that there are no solutions in that box, right? There are no truly very effective solutions that aren't costly or don't carry risk. Okay, and so this in conservation speak we call a true wicked problem. It means that managing elephants really is an issue, and that's what we'll unpack in the next month. And so just some take-home messages and discussion points that we can now touch on. I think that insular reserves in particular need proactive and executable management plans. It's really important. But the context really matters, and any management decision is going to have pros and cons from a variety of sources. Okay, I think there's a lot of loud voices and a lot of talk is going on, but I think we really are in need of rational and civil debate that must continue, and it must be underpinned by evidence. And I think it's important to highlight that such efforts really are underway, and you're going to hear from some of those speakers in the coming weeks, especially in designing the National Elephant Heritage Strategy. And a lot of this happens outside of the eye of the media. And sometimes I think the media is a bit unfair with managers on the ground not making proactive decisions. I think this process is very much underway. In the case of Madikwe, and I'll end on maybe a controversial point, a management decision will be taken there either way, right? We're not clear on what that might be yet, but it will happen. So there is a real but diminishing opportunity for a large-scale experiment. Whatever that action is, we can test the consequences of that action for ecosystem functioning and for the ecological functioning of elephants. Okay, and I'm happy to take questions and have some discussion. I know there were some questions already, and I see there are a few hands going up. I'll stop sharing my screen.
Thank you very much for setting the scene for us. I see Ryan's hand is up immediately, so fantastic. So that is how you ask a question, or if your connectivity is low or you're shy, no need to be shy, but you're welcome to also answer or ask your questions in the chat. We will deal with them one by one, but it would be great if you're willing to talk live. That helps a lot for you also to get the maximum satisfaction from the interaction. So with that, let's start off with Ryan's question. Ryan, please go ahead. You're welcome to unmute.
Great, guys. Thank you so much. I tell you, the biggest concern for me is that it blows my mind. And why are we only talking about this now? You know, I said this at the Indaba 2 months ago. It's as if we've suddenly only realized that there's a problem. I mean, surely we've known there's this problem over the last 3 decades. So that's one issue. I've traveled Botswana extensively, Zambia, Mozambique, and Zimbabwe. Everywhere I went, people, the communities, the game reserves are saying the same thing, that they've had too many elephants for moons, many, many moons, like decades. And so, you know, Rob, you talk about the corridors opening up these areas. I don't understand how that's going to work, because they're not sheep. How are they going to go from one area to the other without human-wildlife conflict? Are you going to build fences of 200 meters wide to just herd them from one area to the other? And then aren't we exaggerating the problem by now opening up new areas for these elephants to now multiply even more? But everywhere I go in South Africa and neighboring countries, we're talking about the same thing. There are too many elephants, too many elephants, too many elephants. And this surprises me that we're only now stating how serious the situation is. Surely we should have done this a couple of decades ago. Like, what has been the delay? Couldn't we see the numbers growing?
Rob and Bernard, I don't know who wants to go first. There's
All
been
right,
a lot raised.
Thank you very much, Ryan. No, we certainly share your concern in the whole series of it. Sometimes you've answered yourself and we agree. Other times you've asked questions and we don't have the answers yet. It's hard to say why we haven't responded yet. It's a complicated situation for a number of reasons. Our work is simply just to evaluate the outcomes of an intervention, for instance, from a scientific perspective. So we would never tell anybody to do X, Y, and Z in order to feed A, B, and C or anything like that. So we only advise the whole process in terms of getting evidence-based information for people to make informed and responsible and accountable decisions. So in many ways, in all the topics and all the things that you've raised, we share your concern and we need to deal with this as soon as possible. There's a number of us also in this audience working very hard finding workable solutions. And it's really pushing us to the limits. Some of the very senior people in this audience are being challenged about the scientific and ecological questions that you've raised, over and above social, political, and economic aspects that all links in with it. So I wish I had a simple answer for you. I don't, but we certainly are working very hard at, rectifying the situation as much as we can, using evidence that we can evaluate. That's the most important thing for us. Thank you for that.
Can I just ask one quick question before you carry on, Bernard and Rob? Who are the gatekeepers? Who is preventing us from managing these numbers? And who's allowed it to get to where it is?
So, Ryan, if I can just, I'm going to allow both of them to speak, but we are going to have some of the managers from various agencies, and I'm not saying they are the gatekeepers, but, who are tasked with these responsibilities later in the series. So stick with it. Rob, Bernard, do you want to please expand?
I don't know, really.
Yeah, Ryan, I think that question oversimplifies a very complicated situation. There's not a physical person sitting there magically making elephants grow. This is a natural process that we're trying to understand and manage. There's not an entity in the wrong here.
No, Ryan, your point is noted, and
Thank you.
very much so. Stakeholder values and perceptions are part of the emerging issues that forms part of a larger debate. that is shaping this conversation. So exactly what you mentioned is exactly the type of things that are being considered in terms of stakeholder values, etc. So thank you. Your points noted. All good.
Great. Thanks, guys. Appreciate it.
Ryan, thank you for your question. I'm going to go to Jeremy next, and yeah, I want to just return maybe at some stage, Bernard and Rob, if you can maybe just at some stage outline for us the process in terms of how you see it, where the role of science, the role of managers of the elephant populations, and the role of policymakers and government, and where does who fit in? Maybe that's what people want some understanding of as well. Jeremy, your question, please.
Thank you. It's not a question. It's just for Bernard. You know, in order to expand the protected area, you would logically go eastward toward Pilanesberg. Now, a great study was done on that more than a decade ago, and it proved fruitless. It was opposed by the mines and the private sector. But the biggest issue now is that Madikwe, the ungulates there are infected with bovine tuberculosis. So if you expand Madikwe anywhere, you're going to expand the disease into an area where more and more people with cattle are compromised with HIV, you know, so that's not a smart option, you know. Secondly, as in 2006, we did the revised management plan for Madikwe, and we recommended 250 elephants, you know, based on carrying capacity, which is now, it's being belittled. The issue of carrying capacity is being knocked everywhere. We then had a workshop in 2007 to decide what to do. And an eminent professor said, don't worry, the elephants will regulate their own numbers. And we're now beginning to see that take place. You know, the elephant are regulating their numbers, dying of starvation. Had they stuck to 250, you'd be culling 6% of 250 per year. So the answer is not to let it get to the stage where you're reaching carrying capacity or exceeding it. You've got to start managing your population well below that, you know. That's my view. Yeah.
Yeah, Jeremy, thanks. Of course, you're right. I think, you know, I had one slide to overview something like protected area expansion. It's, as you point out, for those reasons, it's almost unfeasible in Madikwe. I'm aware of those plans and aware of all the challenges, which is why I try to highlight that it might be a good long-term solution, but it's very complicated, right? It requires buy-in from a lot of people. And yeah, I think one of the things that resonates in the room is that you know, this is again an emerging issue for a reason. I think a lot of people are, as we should, having discussions about this.
Yeah, I think, you know, the staff were led to believe that if they left the elephant population alone, it would control its own numbers. And now we're actually seeing it very graphically on our screens, you know. And, you know, had it been stuck to the original one based on carrying capacity, we'd been culling what 15 per year, which is very manageable.
Any further comments, Rob, Bernard, on that, or can I go on to Don's question?
No, point taken.
Right.
I mean, for a long time, the translocation of elephants into Madikwe was regarded as the greatest conservation success story ever, by the sheer numbers being transported from Ghana Reserve, full family units to Madikwe. We regarded that as a conservation success, not knowing what the implications thereof is. Now we have a better understanding 24 years later, since all the introductions and removals have taken place. So we live and we learn, and we need to be better at it, type of thing. So points taken, and we're working hard on it. Thank you.
Don, please raise your question.
Thank you. Thanks very much for the excellent talks. My question is for Bernard. I'm an economist, so I ask the usual kind of question, which is about trying to make sure all our costs are actually in the ledger sheet and benefits too. It seemed to me that when you were addressing lethal management mechanisms, particularly culling. There were a couple of cost factors that you didn't mention. A couple of them were mentioned in subsequent discussion, but I mean, obviously, one of them in the specific case of Madikwe, but this would arise in many other instances too. So one of the big cost elements that would be associated with culling would be borne by the ecotourism industry and the lodges, right? And that is a potentially very large cost. And then, of course, there's another cost which comes through an indirect mechanism, but if suppose obviously culling would only, as you pointed out, be anything other than a desperate one-off response. It would only be an actual management approach if there was regular culling. If you practice regular culling, one of the things you'll produce is crazy elephants. And obviously crazy elephants then generate a whole bunch of other costs, some of which are very, very large. Now, do you agree that those costs should be, and you're probably in a longer and less stripped down presentation, I reckon you would have included them. So
the short answer is yes. No, I think the what I was trying to highlight is some of those hidden costs. I think that's really important. Ecotourism is a massive one. We're trying to attract people to Kruger. You can't turn around and then cull the population and I hope you're going to achieve those sort of numbers. So yeah, I agree. And the thing is, what I can't see from the culling lobby, and I really think the onus lies on any lobby's position to demonstrate this, is what are the consequences of your actions? Can you model it? Can you tell me? Can you walk me through this? Can you show me what the economic consequences will be? Can you show me what this will mean for our reputation internationally, both in the political realm, but also in the these big international agreements that we've signed on to, like the CBD, for instance. And so that's the sort of life cycle analysis I'd like to see.
Yeah.
Thank you.
Thanks for the question, Don. Bruce, you're welcome to ask your question.
Oh, thanks. Evening, Rob. Bernard, glad to see somebody else in the hot chair this time around. We've done all this before. Rob, question for you. In all of the areas where you showed rapid rates of increase, including Madikwe, I wonder if you could just mention something about the fact that many of those areas had very low elephant densities, in fact, very low herbivore numbers in them for many, many decades, and in some instances over 100 years, places like Kruger, for instance. And just for the benefit of the audience, the question I'm asking relates to the fact that if you take, say, 10 hectares of pasture in a reasonably high rainfall area, put 10 cows into it, what they will do is increase at a maximum rate. So the areas that you're looking at with those rapid rates of increase, first of all, have highly artificial vegetation densities. Madikwe is a relatively new place, highly artificial vegetation in terms of the fact that it was created out of farms that had very, very low herbivore densities on it for a very long time. So a lot of what we're looking at is a completely natural response of herbivory to artificial vegetation composition and structure. And what we're seeing is it going back to what should look like under natural conditions, and we're all panicking. I think the great tragedy of Madikwe is that for the very, very first time in human existence, we actually are seeing an elephant population arrive at carrying capacity, and we could record all of the parameters surrounding the controls of that population, and instead we're flying into a panic and grabbing for guns. Maybe you could respond, Rob.
No, thanks, Bruce. Nice seeing you again. We certainly have walked a long path together. I couldn't agree more. It is so important for any assessment that we make is to also account for the historical characteristics, where we came from, type of thing. So what we see today is can only be explained to reflect back in the past, be it whichever parameter you're looking at in the complex dynamics of the savanna ecosystems. What makes the Madikwe one interesting, and as you rightly said, is really the history of that reserve. And we're working very hard to just try and teasing it apart to try and understand it a little bit better. Landscape variables. There's also aspects about the procedure being followed when the founding population characteristics, the highly skewed sex ratios, gives us growth rates that we resisted to believe for a near 2 years looking at it, because we just simply couldn't believe that a number of elephants could increase at that rate. And it turns out it's, the skewed sex ratios of introduced animals was part and parcel to it. Now, I'm saying this without having it published, but we're working very hard and getting the numbers right and making sure that we're doing due diligence here. Now, with that, understanding the consequences thereof, colleagues of mine also in this audience, we're working very hard in trying to sort of building up simulation and prediction models in terms of how to better understand what did we do, what happened, and where we now, so that we can be better informed in terms of going further. Because we don't just stop here. Forecasting models based on simulations in the past needs to tell us how to best move forward on it. So we're working on that. A number of other things I think Rob Slotto's group illustrated over the decades since we've introduced these little small founder populations, the whole eruptive growth effect because of a number of unstable or incomplete age structures, instabilities. We look after the animals very well, so they just flourish, and they are showing us all the signs thereof. So yeah, indeed, couldn't agree more. Thanks, Bruce.
You want to react?
No, I think Rob captured it. I think it's I think I highlighted Madikwe because it's a particularly complicated case. I think the important thing to understand is that local context. It's so important. People tend to think about these problems in very short time frames and time scales. These systems come with millions of years of history. We're trying to sip the complexity of these systems through the narrowest of straws. I think that's important to recognize, as to Bruce's point.
Mm-hmm. Right. I want to quickly turn to a question in the chat. It's a nice research-related question from Gustav. How can multivariate analysis enhance elephant management by revealing complex interactions between population dynamics, habitat use, and veld condition across multi-species landscapes? It's a loaded question. Good one for the students in the room.
Yeah, I think our preference at this point in time is to just work with population simulation models, and then thereafter include all the other very, very highly complicated interactions on all the trophic levels when it comes to savanna ecosystems. Professor Norman Owen Smith has spent his whole career partitioning it out just to give us an understanding of how complex it really gets. And if you put a fence around it, you double the complexity. So yeah, I guess at the descriptive level, that may help, not so much at the predictive level. Just my opinion at this point in time without having done it myself.
Yeah, I'm not sure what the question is, other than saying yes, multivariate statistics, PCA is one of them. There's a whole family of them are useful for a range of things. I can elucidate some of these relationships. You might also want to look into something like structural equation models, because they're more predictive. Bayesian frameworks might be more interesting because you can build in priors. I think that's what you're getting at. You're sitting with a very technical problem, so you're welcome to email me if I can provide more context and something like that.
Thank you very much for the offer, Bernard. Kabarum, please go ahead and ask your question.
There we go. Thank you very much. Correct pronunciation is Rium. Okay, there we
Rium.
go.
Thank you.
Okie dokes.
Thank you.
So I'm by no means a scientist. I'm a Wenwi. I lived in the Kruger National Park in the village. I had the joy of raising my children there, and I actually raised them on the elephant meat that we got from the abattoir where Mani Coetzee was manager. And I remember when the culling time, when the period for culling came in the village, I remember how we all felt. It was an extremely respectful, very scientific process that was done. I remember also when we did census, I had the joy of flying in the Patronavia with Salman Hubert a few times, and it was always very scientifically, very accurately done. And I just wonder why the abattoir closed down. I still don't have an answer. I left there in 94. And visiting the Kruger as often as I possibly can. I live in the Kalahari now, so it's a bit far. But I don't like what I see. I don't have the knowledge to be able to measure the destruction of the elephants, but you see them in action and you see the shrapnel as you drive. And my question is just, what would the focus be on rehabilitating the flora once these bulldozers have gone through? I'm obviously not very pro elephant, and that's just personal, and I'm very pro culling. So not adding insult to injury, two questions. How will the flora be rehabilitated, if? And how long would that take? And then why did the abattoir close down? I never knew, and I still don't. Thank you so much. And thank you for your time. Thank you very much for this conversation. I'm really looking forward to it.
Thank you for the question. Maybe just to preempt, Bernard and Robert both unfortunately don't work for Sandbox, so they might not be able to take responsibility for all those questions.
That was going to be my answer.
But please go ahead, Rob and Bernard.
Rob, you want to take this one?
Yeah, happy to do that. The abattoir closed down because they stopped culling, so that answers that question. Thus far, we're currently working intensely to try and see what the impact of an increased densities in Kruger Park is for diversity, biodiversity, the species richness. Have we lost any species? I did an analysis of this in 2008 and repeated the exercise in 2017. We're 10 years later, so we're busy working on that. We just appointed a PhD student, and as we speak, as a good PhD student should be, she should not be listening to this presentation. She should be working and analyzing her data. So Bernard and myself, that's our forte, is basically assessing what the consequences of elephant presence to biodiversity is. So we share your concern and we're addressing it scientifically. The previous studies that I did in pulling all the work together in one comprehensive assessment, we did, and I could not see a change in species diversity. What we did see is a change in the vegetation structure, the architecture of savanna ecosystems, and we should not relate that to a change in diversity and having lost species. That's not necessarily true. But we're keeping our fingers on it, working hard at it, and happy to share any other information as it comes out. All peer-reviewed. It's our work, but we get evaluated by people outside, like Professor Norman Owen Smith. He loves to keep us on our toes. Thank you.
Thank you for that, and thank you for the question. We've got about 8 minutes left with Bernard and Rob, and thank you for your time so far. So I'm going to give maximum time to as many people as possible, and then do join us again next week as the conversation continues. Dave Balfour, please go ahead and ask your question.
Thanks, and thanks to everyone who's spoken. I really want to make a comment, which is we've spoken a lot specifically about elephants in protected areas. What we haven't done is taken a slightly higher level view, which is what we're trying to do is to manage a complex system. So there's enormous complexity in an ecosystem, and we're doing that in the broader context of trying to meet societal objectives. And I don't think society has actually established clear and agreed consensus type objectives. So a lot of the debate that we're having, we can get into the weeds of the biology and whether animals are density dependent or whether there should be more tall trees. But I think it's always really useful to step back and say, what is the bigger picture we're trying to do and the complexity of it, especially the complexity of setting objectives. Thanks.
That's a short answer.
No, just fully agree, Dave. I think you're spot on.
That seems to be a very, very valid point, that it's difficult to manage when we can't make up our mind what we are managing for. Shasha Mulder, please go ahead and ask your question.
Yeah, the question that I want to ask is more like a statement rather than a question. Is the situation that we're dealing with, just for some background, I'm a game ranger on one of the mining companies next to the Kruger. And what we experience is all of the passive management approaches that Kruger puts in place kind of just overflows into all of the properties you kind of next to the Kruger. Like in the last 5 years, our numbers on elephants have gone from 60 to over 200 on a 6,000 hectare property. So it causes a big issue for the properties next to Kruger when they try to passively manage the numbers. And I think something that needs to be looked at is kind of having a collaborated approach, especially in areas that borders Kruger and that's got an area with so many elephants. Because at the moment, every little property next to the Kruger is managing in their own little way and doing it for their own little reasons, like Dave just said. And I think that's where one of the biggest problems come in, is there's no cohesive management plan. There's nothing being done for the whole area. Everybody's kind of just trying to manage their own little piece of land.
Thank you for that. Bernard and Rob, your comments on that?
Yeah, I'm not 100% sure about the whole situation in the landscape that you work with. There are people in the audience that are much better suited to do that, be it members from APNR or the Greater Kruger region. Of course, we share your concern, and if you manage wildlife on a relatively small area, but it's connected to other areas, whatever your neighbors is going to be doing, it's going to be affecting yourself. So point taken. Unfortunately, I'm not all that familiar with the technicalities on the ground there.
Okay. Thank you. I'm going to go to Jeremy. We've got about 4 minutes left. As I said, do join us next week. We'll have more experts joining that can perhaps also answer these same questions from different perspectives. So Jeremy, please voice your concern or your question.
Thank you. Just a question for Rob. On your map, you showed the increasing populations and decreasing populations, and you had Kruger as a stable population. Are you sure that's right?
Yeah, they fall in with between plus and minus the 5% growth rate.
So a 5% growth rate, it's regarded as being stable.
No, it fluctuates around 0.
So it doubles every 30 years.
A little bit faster than
that. A little bit less than that. Faster than that.
Yeah. No.
So shouldn't it be in hatched blue? On your map?
No. Above 5 was blue.
So yeah, no. That was just a query.
No. 5 was just if you have a spectrum of growth rates across 103 populations, somewhere along the line, you need to bin the categories. So in order to make it a bit more practical, there's some follow-up work happening there. But the white was indicating plus and minus 5%, which is close to an immortal elephant population at maximum growth. Yeah,
I don't agree. I don't agree with that, Rob. I think it's not a stable population. If it's 5%, it's not stable. But
no. If it's zero,
I just wanted to say that
if it's zero, it's stable. Minus 5 and plus 5, 0 is stable. No, but I mean, if you don't agree, then you could just publish it and we can have a look.
No, Kruger's not stable. It's not stable. Kruger's an increasing population, but I just wanted to
bracket that we're dealing with. It's growing. It's increasing at between 4.2 and 4.7, and declining rates over the last decades. We're working on that with members in the audience, and happy to share it with you.
To say that after the 2007 workshop at Madikwe on the Madikwe population, we were so concerned that we put in a memo to MTPA predicting what has happened now and stressing the need to monitor. As we said, it would become a case history, and I think Brian Child is already going to use it as a case history. So we predicted that in 2007. That was a flag was raised a long time ago.
That would be the most valuable information. If you can share that with me, I will send it to you. That would be awesome, simply because that's part and parcel of lessons learned. If there's a red flag coming up, we need to respond to it. If you have raised it in the past and nothing was done, that's a lesson learned, and we can work from there onwards. Please do share it with me.
Send me your email address and I'll send it to you.
Okay, I'll type it here in the text box if I know.
Thanks, Rob.
All right. Okay, with that, it is exactly 8:30. So I am going to call it a night. And thank you for all of you for raising difficult but necessary questions. And the conversation in the chat was very, very lively. I hope that we've connected people who will be talking that haven't spoken to each other before. And that could also lead to new lessons learned. To Rob and Bernard, thank you very much for sitting in the hot seat. We really appreciate it. Hope you will be able to join us next week. It would be fantastic if you could join the conversation again. And thank you to the speakers for next week, Sam and Janetta, who are already here. We look forward to sharing the time with you next week. Thank you, everybody. See you soon on the next conversation.